Hi everyone, and welcome to our video on the lowering power formulas. So the lowering power formulas come from the double angle formulas for our cosine function. So our cosine, as a reminder, the double angle formula for cosine had three instances. So there's the main one, I would say. But then we also had 2 cosine squared theta minus 1. And we also had cosine of 2 theta was 1 minus 2 sine squared theta, like that. Okay, so there they are. Well, where this comes from, or where these two come from, is by taking these two and solving for the cosine squared or solving for the sine squared. So for instance, like on this bottom one, let's do this bottom one right here. So I want to solve for sine squared. Let me erase that arrow. So I'm just picking that bottom one and saying, well, if I want to solve for that sine squared, I should minus 1 over. So then we would have negative 1 plus cosine 2 theta equals negative 2 sine squared theta. And then if I divide everything by negative 2, okay, so the negative 2 divides everything, and we would get 1/2 minus cosine of 2 theta over 2 equals sine squared theta. And then we can see, oh, that is this one, just with the denominator already made to be a single fraction and the sine squared on the left. Okay, so that's our sine squared lowering power. And then our cosine squared, we could have done the same thing with this second equation to get this lowering power equation. Okay, and then tangent, if we need it, I would say just do sine squared over cosine squared. It will eventually simplify into that right fraction if we wanted to keep working with it. Okay, so however, these lowering power formulas or power reducing formulas are pretty rare. We use them again in calculus. So if you have to take calculus, is when you probably will see them again. What we like to do is just show the manipulation with the double angle for our scenario here, and then eventually we'll get even more formulas. So and notice with our double angle too, just to go back, our double angle we said was from our addition. So let's scroll all the way. So we started with these addition formulas. Using those, we got the double angle formulas. Now using the double angle, we're getting these formulas, and then one more coming soon. Okay, so we just keep building off of the same kind of intro formula. All right, well, anyway, let's see how this works. So use the power reducing formulas to rewrite the expression so that it does not contain powers of trigonometric functions greater than 1. All right, so what it wants, they're saying they don't want any powers of 2 or more. So we see we have squares. So they're saying change those. Well, sine squared of x is right above. We just did it. Also, one thing to note is that they notice how similar they are. Sine squared differs though with a minus, cosine squared differs with a plus, but otherwise they're the same thing. Okay, so they look the same, just a different sign. All right, so what we've got on this, the sine squared would be the 1 minus cosine of 2x over 2, and then the cosine squared would be the 1 plus cosine 2x over 2. And then if we need to, we can put a 1 under that right there. Okay, and the way that I'm going to do this, so the 1 times 2 down below, that is 4, and I'm just going to group it with the 20. So 20 divided by 4, and then that one we will reduce. And then I also have the 1 minus cosine 2x times the 1 plus cosine 2x. Well, what they're going to want in this scenario is for us to FOIL this all out. So I'm going to change the 20 over 4 to be 5. And then I'm just going to get a big parenthesis going, but let's color code. So I'm foiling. So 1 times 1 is 1. 1 times cosine 2x is cosine 2x. And then negative cosine 2x times 1 is negative cosine 2x. And then negative cosine 2x times positive cosine 2x. So those are the same cosine functions getting multiplied. It is minus in front, but the same thing times itself would mean that it's squared. So cosine squared 2x. And then inside those parentheses, we can see, oh, let's simplify a little bit. These middle terms are the same but opposite, so they'll zero out. So we've got 1 minus cosine squared of 2x. And if it helps, I'm putting the parentheses now on that, but we could have done it the whole time. Okay, so that's just a preference thing. I chose not to do it until this step. All right, now let's continue with this. Okay, so inside the parentheses, we can continue simplifying. What we're going to do is change the cosine squared. So again, we have a square again. So it's saying, well, we need to change that. Okay, so this we need to change. And we're just going to use our double angle formula again. Okay, so to the side, let me write it out so that I can see it without scrolling. So the cosine, we use 2 theta, oops, sorry. We use theta, and then the 2 theta. So cosine squared theta is equal to big fraction 1 plus cosine of 2 theta over 2. Okay, so what's happening here is this angle is doubling. And then we still have to remember the other stuff, but that's how I want to rewrite this. I'm going to think, let's get a big fraction. Let's do 1 plus cosine, and then let's double this angle. Double it. Okay, so a little messy, but I think it's okay. Double it. Doubling is to times 2, so let's times it by 2 to get 4x. And then still over 2. Okay, so that's the rewrite of using that double angle formula. All right, and then afterwards, let's rewrite it one more time to say, with the parentheses, I'm going to break up this fraction. So I'm going to say it's 1/2 plus cosine of 4x over 2. And the reason for that is it looks like I have constants that I should combine. And so when we distribute the negative, we'll have 1 minus 1/2 minus cosine of 4x over 2. And then we can see, oh, those constants, the 1 minus 1/2 is 1/2. Oops, I wrote 5 equals. It should be 5 and then parentheses 1/2 minus the cosine 4x over 2. And then for a final step, I'm just going to distribute the 5. So we'd have 5/2 minus, I'm going to write it as 5/2 cosine of 4x, like that. Okay, so there we go. So that's rewriting it. So now it no longer has any powers of higher powers than 1. It is a stranger angle though, 4x. Okay, so we start with x's, now we have 4x, but at least there's no powers on it. So often, especially in calculus, sometimes powers on trig functions are problematic, but this usually has no issue with it. Okay, so that's using the lowering power formula. If you do have questions, please let me know. Otherwise, thanks for watching.